All right, this is part 2 of section 3.4. We're trying to find g of f of 3 now. Okay, so g of f of 3. So first we're going to work with the innermost part, which is 3. So that's like f of x. So they're saying that x is 3. So I'm going to go down to 3. And then I'm going to go within the function f. I'm going to work out. Okay, so that's 3. So now this is like g of 3. So now I'm going to go down to, get rid of these. I'm going to go down to 3. I'm going to go all the way over to g. So that's going to be 2. Okay, now let's use graphs to evaluate composite functions. So instead of reading all this, let me just show you how you do it. Okay, so we're going to use the graph to evaluate f of g of 1. And it says right here that this function right here, parabola open upward is g. This parabola open downward is f. So we're going to work with the innermost, which is g of 1. So I'm going to start with this function right here, g. Now g of 1, that's like saying that x is equal to 1. So I'm going to go to my x values, go to 1. Then what I'm going to do is I'm going to go up to the function, and then I'm going to get my g of 1 value. So g of 1 is equal to 3. So now what we can write is f of g of 1. Now we know this whole thing right here is just 3. So this is f of 3. So now I need to go to f of x. So I need to be over here. Now this is saying that x is 3. So I'm going to come over here to my x values, 3. I'm going to come up to my function. So f of 3 is going to be 6. And that's my answer for f of g of 1. This whole thing is equal to 6. Now let's look at g of f of 2. So first off, I'm going to look at 2 within f. So I'm going to be over here. I need to go to 2 for my f value. So go up. So f of 2 is 5. So f of 2 is 5. So g of f of 2. So we know that this whole thing right here is 5. So we have g of 5. Okay, so within the g function, so now get rid of this. Now I'm within the g function over here. I need to go to a value of 5. So go up. Now g of 5 is going to be equal to 3. So that means that g of f of 2 is equal to 3. Okay, now let's use formulas to evaluate composite functions. Okay, so let's just go ahead and use this one. So we've got two functions here, f of h of 1, where f of t is t squared minus t, and f of x is 3x plus 2. Okay, so what I'm going to do is I'm going to take h of 1. So that's going to be 3 times 1 plus 2. That will be 3 plus 2. That will be 5. So that means f of h of 1, well, we know this to be 5. So we're looking for f of 5. Okay, so I'm going to plug 5 in. So there'll be 5 squared minus 5. So that would be 25 minus 5. So our answer would be 20. So f of h of 1 is equal to 20. Okay, so f is going to be x squared plus 1. G is going to be square root of x plus 2. First, we're going to find f of g of x. So that means we're going to take g and we're going to plug it into f. So wherever I see an x within f, I'm going to replace that with my function for g, which is the square root of x plus 2. So this is going to be not x squared, but the square root of x plus 2, that whole thing squared, plus 1. Now I've got a square root and a square. These two things cancel each other out. So I'm left with x plus 2 plus 1. So that is x plus 3. And then we're going to find g of f of x. So now what I'm going to do is I'm switching it. I'm going to take f, and wherever I see an x within g, I'm going to put my function in there. So we're going to have the square root of not x plus 2, but x squared plus 1 plus 2. So this is going to be x squared plus 1 plus 2. So that would be x squared plus 3. And that will be g of f of x. Okay, let's try this one. So f of g of x. Okay, I'm going to take cube root of not just x, but x plus 1 over x cubed. Now, anytime I've got a fraction within a square root, we're going to divvy that up to x plus 1 over the cube root of x cubed. Now, these are going to cancel each other out. Well, not cancel, but I have 3 x's because this right here is x times x times x. I need 3 of the same thing to pull 1 out. Okay, so what this would be is cube root of x plus 1 over x. Okay, and then we're going to switch it around. G of f of x. Okay, so now I'm going to have the cube root of x plus 1 over the cube root of x, and that whole thing cubed. Okay, now these do cancel each other out. Okay, they cancel each other out, and what I have is the cube root of x plus 1 all over x. Okay, so there's your 2 answers. Okay, this one we'll look at f of g of x. Okay, so we're going to take 1 over not x minus 6, but 7 over x plus 6 minus 6. Okay, well, these cancel, and I'm left with 7 over, or sorry, 1 over 7 over x, which really means I just flip it. So this would be x over 7. And then g of f of x. Okay, so we're going to have 7 over not x, but 1 over x minus 6, and this whole thing plus 6. Okay, so we're going to have 7 over 1 times, flip it, x minus 6 over 1 plus 6. Okay, so what I have is 7 times x minus 6, and then plus 6. So that's going to give me 7x minus 42 plus 6. So that will be 7x minus 36. And that's your answer for f of g of x. Okay, and then let's go back and do g of f of x. Okay, so this would be, oops, sorry, I already did that one. Let's move on to the next one. Okay, so now look, we've got 3. We've got f of x, we got g of x, and now we've got h of x. And we're looking for f of g of h of x. Okay, so I'm going to put h into g, and then I'm going to put g of h of x into f. Okay, so first off, let's look at g of f of x. Okay, so it's not going to be x minus 6. It's going to be the square root, of x minus 6. And then f of g of h of x. Now I'm going to put this whole thing into f. So this is going to be the square root of x, this whole thing raised to 4 plus 6. And I forgot a little part. Minus 6, that whole thing raised to 4 plus 6. Okay, now we could expand out the x squared minus 6 raised to 4. We could expand that out, but I'm going to leave it like this right here. So this would be our final answer for f of g of h of x. Okay, now let's look at this one. The function h of x is equal to the square root of 5x cubed minus 2, and that can be expressed in the form f of g of x, where f of x is the square root of x, and g of x is defined as what? So they're saying that f of x can really be defined as a function within another function. And they say that f of x is the square root function, which means g, which it already says here, g, the function g is put into f. We already know that f is a square root function, so that means that g would have to be what's underneath the radical. So that would have to be 5x cubed minus 2. Now if we say, okay, f is the square root of x and g is 5x cubed minus 2, if we just took those and we looked at f of g of x, well, we would say, okay, this is going to be the square root not of x, but of 5x cubed minus 2, which is what we get right here. So that means that g has got to be 5x cubed minus 2 if f is already that square root function.